Hey, welcome everyone to this webinar.
Good afternoon.
Yeah, thanks for being here. We appreciate it a lot. Today we will talk about Excel sheets and how you can turbocharge them. Next to me is Roland.
Hello.
Welcome, Roland. How are you doing?
Yeah, good. I'm a bit nervous about this, to be honest, but I think it's healthy nerves. So I'm sure we'll make something nice out of this.
Yeah, and you will soon become father for the second time.
Yeah. So I'm a bit nervous about this, a little bit more nervous about that. Next week actually. So this is one of the last things I'll do for a while, work-wise.
We don't get the call during the webinar.
No, indeed. Yeah, I told it on the front, like if I get a phone call, I will have to answer it. So you'll be looking at just another for the rest of the webinar.
Yeah. So we will be waiting a few minutes until everyone arrives. If you have any questions or comment, just let us know. We will we can put the question on the screen and we will react to that. But in the meantime, Roland, maybe you can tell us a bit about your background on engineering and automation.
Yeah, of course. Yeah, I've been trained as a mechanical engineer. What feels like a lifetime ago, but I think it was actually only 10 years.
Okay.
I studied mechanical engineering, did my master's at university, and then had a few different jobs. And finally, 7 years ago, landed here at Victor, where I've been very happy combining the programming love that I have with my engineering skills.
Yeah.
So yeah, I've built a lot of apps for a lot of different customers. And I hope that I can showcase all the hard work we've done at Victor to try and make that easier and easier still in this webinar.
Yeah. And the $1 million question, do you still use Excel?
Absolutely.
Yeah.
Absolutely. Yeah. I mean, Excel, it's a great tool. It's very intuitive for lots of people to use. It's great for creating overviews. And I've also seen a lot of scenarios in which, it starts as an overview, some nice tables, and then it grows into this calculation thing.
Yeah.
And as projects grow over time, they become more and more sort of vital to the core of the project. And I'm sure you have some experiences with that as well.
Yeah, me too. But before I tell my experience, I'm wondering, you people at the office or at home, what's your experience with Excel? And maybe you can share with us what you like most and what you don't like about Excel. And during the webinar, we can take those points and maybe discuss a bit about it. But I also use Excel quite a lot. For like simple things, keeping track of tasks and other stuff. And maybe there was a time I used it quite a lot, actually. I think Excel was also the reason why I ended up going into programming more seriously. And it was when I made an Excel sheet to calculate the glass fiber flanges. And those flanges, they're complicated to calculate comparison to steel. And it calculated the flange, and on top of that, it generated all the machine codes to drive a CNC machine. So you generate the code, load in the machine, and then the machine start make these flanges.
Yeah.
And at the moment, I was super proud about my Excel sheet, of course, but it was, in all honesty, it was kind of a monster. So I was kind of the only one that was able to use that Excel sheet, and it was not a very scalable solution.
Yeah.
What about you? What's your favorite Excel sheet?
Well, actually, I did a project where I built a solar car at one point, and that was also, I think, a classical example of it. Started out as the sheet in which we kept track of all the components and their weights, trying to estimate the total mass of the car.
Yeah.
And then, we added the functionality to also calculate the center of mass, and then the center for aerodynamics, and then
quite advanced.
Yeah, and it became sort of key in the whole calculation. Like every other calculation touched or started with that sheet.
Yeah. For me, it was the same. So I started doing this app, and then I kind of found the limitations of it, and I think I made a mistake at the moment. It was trying to improve that Excel sheet, creating macros. So I started learning VBA, and I started doing these macros, and it was working, but I didn't realize at the time how difficult it was actually. So it was very hard to learn, very difficult to keep track of all changes in those macros. And then I kind of remember my time in the university when I had MATLAB, and I say, okay, there must be something similar to MATLAB, but free, because MATLAB licenses were quite expensive. And then is when I actually kind of discovered Python and started like going into programming again. And I say, oh gosh, why did they even start with creating macros?
Yeah,
because, it's such a pain.
Yeah, and from that on, everything has been easy ever since, right?
Yeah, it's easier. It's easier.
It is a lot easier.
Yeah. Cool. So in today's webinar, we will talk about a few things. So we will have a short introduction about what is Vector, because that's the tool we will use to turbocharge the Excel sheets. And then Roland will turn an Excel sheet into a web application, and using a tool for that, so like a converter. And as a last step, Roland will will make an app with Python from scratch, which also includes an Excel sheet. So I will say let's get started. And I want to start with a short introduction about Vector and what we stand for. So we stand for Automate the Boring and Engineer the Awesome. And we see two things happening in the world. So the first one is that we have very big challenges. So global population is growing. The sea level is rising. We have global warming. And as a consequence of that, we are having each time higher requirements on the things we build. So they need to be we need to build faster. They need to be cheaper, and they need to have less impact on CO2. And that contrasts a bit with the other thing we are seeing, and that there is actually a shortage of engineers. So, for example, the four of the biggest universities in the Netherlands, they wrote an article saying that the shortage of engineers is actually, a threat to a sustainable world. And that's not only in the Netherlands. For example, the American Society of Civil Engineering say that there are simply not enough engineers to tackle research in infrastructure projects they have at the moment. And in Australia, they say they are facing an engineering skill crisis by 2040. And there's also another quote that I read that they're saying that by 2030, 20% of the engineers in the UK will be retiring. And what's the consequence for us engineers at the end? A lot of work. So we will have a lot of work, a lot to do. And I think we're noticing this, so we're running from project to project, from deliverable to deliverable. And if we're honest with ourselves, not all that work is so fun, so there's a lot of boring, repetitive work on it. So updating new models, post-processing the results, updating reports one over and over again. And I think that's the main drive of, at least for me, it was the main drive to start really creating tools, using Excel and Python, Grasshopper, Dynamo, to create tools that really help us with this. And I have seen some challenges that I have faced personally. I think you run too, and also like other people we talk. And it is, first of all, that we don't have a lot of time to create those tools. We are running from project to project. We need to be billable, and we don't have the time. So really need to create the solutions quick. But also in the software we use, there are limitations. So you can do a lot with Excel or Dynamo or Grasshopper, but you cannot do maybe all you want. Or maybe there are a lot of possibilities, but the skill level you need to do it, for example, in Python, can be quite high to make a really professional tool. And let's say you have a tool and you like it and you think it will provide value to other people. You want other colleagues to use it, then there are some challenges there too, So not all tools are user-friendly. So a simple Excel sheet is easy for other people to use, but when they get bigger, like maybe the Excel sheet you made and I made for the flanges, it's very difficult that other people use it without making mistakes in it. And it can be, it's not that easy. Not to speak about Python script. It's not that everyone can use that. And data control, So let's say you use one of those tools together with a colleague, and one changed the length of the bridge and the other one the height, and you don't have track of what happened in the tool and why changes were made. So there could be some confusions. And what I also have seen quite a lot is that there's no logic control. And just to give an example, what's typical is that you make an Excel sheet just to take an example. You put it on the hard drive of the company, or it can be a Python script, it doesn't matter. And people start using it, they start modifying it, and oops, you discover a bug after 2 weeks. And then you change that, put it on the drive, and then send a mail like, hey guys, I found a bug in the script, and actually you should change it.
Yeah.
But there's actually no way to make sure everyone is using that.
Please use V2 from now on.
Yeah, that's simply not really working in practice, and I have seen this gone wrong in real projects, and it was not fun. So yeah, we saw it as engineers ourselves. We experienced these issues, but we didn't find a solution, and that's the reason why we created Victor, to be a solution for this. So what's Victor? Victor is actually a platform that empowers engineers and other domain experts to build and share user-friendly web applications. At the end, to automate your workflow. So it's to automate your workflows. And I say that's user-friendly because the apps you make are similar to this. It's a user interface with buttons and sliders, where you don't see the Python code, you don't see that big messy Excel sheet, and so more people can use it. And the way you build those web applications, and Roland will show that later, is by using Python. So you build this with using Python, but it's not Python on the level maybe someone of Google will know. It's Python on the level that engineers know. So it's kind of basic Python. And we also have helpers. So we created several tools to help you. So for example, we'll show the Excel converter, which helps you convert an Excel sheet into an app. We also have other tools with, for example, a chat assistant that helps you write code. And we have other tools here to help you. And what's very, very interesting is that soon we will release a no-code version, meaning that people will be able to make apps without having to know anything of coding. And it looks like this. Now you can click and add your input fields, different tabs, whatever you want to add. And then you can also, just add the visualizations you want. So I'm really looking forward to that. I think it's a real enabler to get everyone on board of automating. And by the way, if you have any questions, again, just ask them in the comments and we will come back to them. So if you have an app made with Python or any tool, you can also connect that app to different software tools. You can connect it to, for example, finite element package and then geotechnical software and some drawing of modeling software and use Python libraries. So you can really connect everything with the aim of automating a bigger portion of your engineering workflow. And the last step is, of course, when you have that app and you want to share it, we also help you in that. So, for example, if you use your company uses Victor, your company will have this environment, which is kind of a private app store where you can find all the tools your team has. Therein, you can save the project data, you have version control on the data. So it's a really easy way to find the tools you have available. And all those tools are user-friendly. So it's a good way of sharing those tools inside your team. And it's all done automatically. So you don't need to have any knowledge for doing this. And last, of course, we're aware that automating is also a skill you need to learn. And we want to be more than only the platform where you automate your workflows. We also want to be the place where you can learn how to automate workflows and improve your skills. So we have really a ton of learning material, tutorials, and we will keep improving that. And it's all for free. So you can just join and you will have access to all of that. And I can imagine you're thinking like, okay, but what kind of apps do you make with Victor Not? So to just give you an example, I have here a video of an app that was made by Bansi, one of our clients. Bansi is one of the biggest construction companies in Europe. And it's an app to automate the design of crane foundations. And they do it very quickly. So here you see that they can change like the parameters of the piles and it gets updated automatically. And then this connects to a finite element software that runs the background. You don't see that part and you can calculate the forces and the rebars in the concrete structure. And then you can perform all kind of checks to see if it fulfills the requirements. And you get the drawings made automatically. And on top of that, you get like the engineering report with all the checks and calculations and pictures of the finite element model as you will usually do in an engineering report.
Super cool.
Yeah.
They went really complete, I would
Yeah,
say, right?
yeah,
Like
it's great.
including drawings, reports, everything. It's
Yeah.
impressive.
It's such a time side because they say that before they needed like 4 days full time to calculate this.
Yeah.
Now they do it in 15 minutes. So it gives them like incredible flexibility to just play around and find the best solution very, very quickly.
Yeah.
Yeah.
Super cool.
Yeah, and the last thing, so if you want to start, you can start for free. And it says for free, it's not a free trial, it's really a free version, and that enables you to do a lot. You just go to our website, scan the QR code, and you can start building apps. And with that say, I want to give the stage to Roland, who will show us how to make an app.
Indeed. Yeah. Well, as Anand already mentioned, we're starting to also develop Victor more in the direction of making it easier and easier still. We think Python is a really accessible language. It's, if you write it well, also really easy to read, which helps prevent bugs and keeps it checkable. But still, you have to write Python. And that can be, of course, a barrier. And so we're also trying to create some helpers, as you mentioned. And the one I'm going to show now is actually a helper tool that we created that you can use to take an Excel sheet that you have and generate a vector app out of that Excel sheet. And you don't have to really do any coding yourself. So how does it work? Well, you go to this Excel sheet converter. It's available online. So this link we can share, and you can go here and use it right now. It takes you through this process of these steps. It's based on the assumption that you have, of course, an Excel sheet that you want to create a vector app out of.
Who doesn't have an Excel sheet?
Exactly. And the only thing you have to do is you add 2 tabs to that Excel sheet. So you add a tab called Vector Input Sheet and one called Vector Output Sheet. You can leave all the logic, all the formulas on your calculation sheet as is. All you do is you link the cells on the input sheet to the calculation sheet cells you want to update. And the same thing for the output sheet. It's important to note that this works for Excel sheets that use cell formulas. So that I get that question sometimes. Can I also use this if my Excel sheet has macros? No, for that you would have to use one of our integrations. We do build apps that integrate with Excel sheet that run macros, but this tool uses only Excel sheets that have cell formulas. So I go into this tool, I upload my template, I process the file, and what we do now is we try to read in the file, recognize all the input fields, recognize all the output fields, also take from this sheet the plots and the graphs that were in there.
Yeah. And when you talk about the template, is this something you could show to see what you do about it?
Yeah, and I will also do that later on.
Okay,
I will share a template later on. For now, assume that this template does a beam calculation, which you can maybe deduce from this figure. So the parameters are the length and the width and the height of the beam and the loads. And you can also see that, these are all the plots that are in the Excel sheet. And if I'm happy with how this app looks, I could say, well, actually, let me download the code for this functioning Victor app. You could check out the code here, and you can download it here with this, and you can get this zip file, which I already did in preparation for this webinar, of course. And I have it here. So in here now is a working version of the code I just now generated.
So this is the app you made using the app generator?
Yes.
Okay.
And it's good also maybe to explain that what this app generator does not do is take the logic out of Excel and translate it into Python.
Yeah.
No, this is a Victor app that uses the actual Excel sheet in the background to do the calculations. But it still functions as a normal Victor Excel sheet. So if I update something, you will see that the results immediately update. It has all the input fields that we defined on the input sheet tab and all the output fields we defined on the output tab. All my plots are still here. They are also up to date. So again, if I change something, the plots also automatically update.
And those are the same plots you have in your Excel sheets?
Yeah.
Okay.
Yeah. And what we added also to the app that you get out of this is also an optimizer and a variant study. So let's say I want to create multiple versions of this, because this is really an area where I think people start to run into the limitations of Excel. Right? Okay, this is really handy. I can create a design really quickly. Okay, but what if I want to generate 50 different versions?
Exactly.
Am I going to use 50 different Excel sheets? So what we've done here is, well, I could, for example, say, well, let me create 2 different versions of this. And if I now update, then we will take both of these designs, and for both of these designs, you will get your results. And the same thing for the deflections. If I generate this plot here, we just show both of the results in a single plot. So it's really a lot easier. The other option would be to really do almost like a brute force optimization, where you specify, well, vary the length between 50 and 60 with increases of 2. That would result in 6 calculations. I could say calculate and get all the results.
And people are asking already, can you show the Excel sheet so people can maybe...
Okay. I'll no longer postpone. So this is the Excel sheet that that this specific app is based on. It's a very, I think, well-known calculation for anyone, at least that studied mechanical engineering. I know I've seen a lot of these formulas. This is the original Excel sheet. It's a calculation tab. It has a tab specifically for the plots. It has a tab with some data. And what we did is we added this vector input sheet. And then you will see on this calculation sheet that some of the cells now link to that vector input sheet. And the same thing for the vector output sheet. It is linked to certain cells on the analysis tab. So you don't have to change the logic on your analysis tab. You can leave it as is. All you do is some routing, take some input values from the vector input sheet, and loop some results to the vector output sheet.
Now the graphs also there in the Excel sheet?
Yeah, so the graphs are in here.
Okay.
So, and when you upload the sheet, these are read from the Excel sheet and they appear in your vector app.
Okay, that's quite cool.
Yeah.
I hope that answered the question about how the template looks. And if not, let us know and we will clarify that.
Yeah. Of course, we can always show a bit more about it. But yeah, that's our helper, our Excel to Victor app converter. You can use it right now. And yeah, I think it's a really good step into trying to lower this barrier.
Yeah, what I really like is the optimization function, because that's something I had like troubles with also in Excel. So as long as you can make let's say, calculate everything in a column, then you make many columns and you compare results. But when it gets a bit more complicated and it cannot become a table anymore, that's the reason why I started actually doing macros, is to calculate different like solutions and compare that and like repeating a process. So it's very cool to have that in an app and be able to compare everything just by creating this app.
Yeah, I think so.
Automatically.
Yeah,
cool.
The second part I will show is that, okay, this is a helper, right? It makes it really easy, but there are quite a lot of cases in which you might say, well, okay, but I really want to be more specific. I want my user interface to look a certain way. I have ideas to use different plots than are in the Excel sheets. We have also, if you're building a Victor app from the ground up, so to say, from scratch, some tooling to use any Excel sheet quite easily in our documentation. So I will try now to build an app from scratch.
I have a question about that I will put on the screen. Will you need to upload the Excel file every time? Or is there actually an app?
Yeah, so I think maybe that wasn't then. So this app, the Excel converter, you upload your sheet. Then you click this button, and if I download this Victor application here, this code, you don't have to re-upload the Excel sheet anymore, right? This app is, or this code is a code of a fully functioning Victor application that you can have in your own Victor environment that uses under the hood, so to say, your Excel sheet.
Yeah. So I think that you have the converter, which is an app.
Yeah.
And that app makes another app, which
Yeah.
is kind of Inception.
Exactly. So
and that app contains your Excel sheet, no?
Yeah.
And it runs that Excel sheet on the background.
Exactly. So
Yeah,
you actually see it here. So the code of our resulting vector app, you see that it refers to an Excel file in the background when it does a calculation.
Yeah.
So in the future, if you have a new version
Yeah.
of your Excel sheet, what you would do is you would replace the Excel file in your app repository.
Exactly.
And that's it. Then you republish, and from now on, anyone using this resulting vector app is using the latest version of the sheet.
Cool. I think that makes it clear. And if not, ask the question.
Ask it again. Yeah. But let's also try to build a vector app from scratch, because we also want to showcase a bit how easy that is, and also even in the case where you are going to want to add some Excel sheet in the background.
Now we'll build an app from scratch, not?
Yeah.
Okay.
So what I did is we have the Victor CLI installed, which is a small program that you use if you're a developer using Victor to write your code on your laptop and immediately see the result in your Victor environment. So you can test and experience the app that you are writing as you are writing it. And it's also possible with the Victor CLI to generate new apps, which generates some standard files, gives you a nice starting place. So that's what I have done here. So I'm in my app.py file. This is where my app will live. It has two classes, the parameterization, which is where you define all the parameters that your end user will fill in.
Yeah.
And then you have your controller. And the controller is where all your logic lives. So the user sees a 3D visualization that relates to a function on your controller, a method on your controller that uses the values in your parameterization. Don't worry if I'm going fast. It will be it will become more clear as I'm doing it, because let's just start with building up the parameterization a little bit.
And maybe for people that are not used to programming, we're making this with Python, not? So it's like
this is all Python.
Yeah, it's the usual way you use Python. It's like a code editor which you have on your laptop, as you will do always. And the only magic is that we have installed a little piece of software, Victor, which connects with your web application.
Indeed. Yeah. So I've gone to our documentation, which lives on docs.victor.ai. It's a great place also to get started. You can go through our installation process, and there's lots of tutorials in here that I think really get you up to speed with the basics of Victor quite fast. So I want to add a few fields, some input for my end user to fill in. Well, as you can see here, we have a long list of all sorts of different fields that you can give to your end user. You can upload files, select options from drop-downs, have textual input. For now, actually, let's be lazy, because I like being lazy because I'm a programmer. So I will copy and paste most of the things I'm going to do in this webinar in here. And you see that I save my file, and the app down here instantly reloads, which is nice for me because I can close this converter. If I now go in here, you see that I have a field. And all I did was I added this integer field, right? So it's really, we've really done our best to make it easy as can be. There's all sorts of other fields that we can also add. So I'm going to cheat a bit more and add, for example, these two other fields. You can see at the top here that I'm importing them from the Victor SDK, which is basically a Python package that we built that has all the things like buttons and views in there.
Yeah.
And if I now update my app a little bit, then I have these three option fields in here. So that's all well and good. It's quite easy, as we can see, to add inputs for my user. Now let's also add an output.
Yeah.
So I go to the documentation again. I look at all the possible results. Here you see that we have plots, 3D models, maps, GeoJSONs. There's images. You can show PDF. You can even, for added flexibility, build a small bit of HTML and display that. I will, for this demo, use our 3D visualization, which I will again cheatingly take out of our documentation. And as you can see again, the app uploads or reloads instantly upon saving. And if I go back to my app, I now reload. And there is my geometry view.
Very cool.
So this is the building we also saw in one of your slides, actually.
How many lines of code have you until now?
So I'm on 35.
It's not a lot.
Not too bad, huh?
No.
That's not too bad. It should be, I guess, as you say, like there will be some key concepts that people have to understand, right? And it is Python, so there might be a barrier still. But also, I think we see a lot of people coming out of universities and colleges that actually have learned Python in their education. So they are almost expecting to work with this type of stuff.
And with a nice, also with the Haagse Hogeschool, we had a training on parametric design, and then students actually learned Python for 10 days, and then they start building bigger apps. So it really says something about the level of Python you need to know to build these apps.
Yeah,
we're quite happy to see how enthusiastic they were and the apps they made. That's really cool.
I've renamed some of these fields because I can imagine that you are now looking at my screen thinking, well, that's all well and good, but of course the two things should be connected, right? That's the whole point, that if my user does something on the left side, the result matches. And to do that in Victor, you can make use of this argument, params, which, as you can probably infer from the name, has this list of variables that you've defined. So for example, if I were to do this, rename it to params.floors, because this field has now been called floors, and I reload. And from now on, if I update this, my building will instantly have this amount of floors. So that's how you create the connection between your input and your output. So again, I think somewhat quick to build and hopefully somewhat easy to understand. Yeah, I think what else? It might be nice to also add a map view, because those are nice and colorful, and everybody likes colorful things, right? In that sense.
Yeah, because could you show again which views you have? So we have 3D model, and now we will add a map.
Yeah.
Which other options do you have to show things?
So there's plots, which rely on Plotly, which is a super well-known Python graphing library. You can do all sorts of cool things with it. There's 3D models that rely on the Victor geometry package.
And can you only make them with Victor geometry package, or can you also connect it to Grasshopper, for example?
Yeah, so indeed, you can already see here that it can be based on other files as well, GLTFs, 3DMs, IFC files. So indeed, you can connect this, and we've seen lots of customer cases for this as well, where it relates to other CAD software.
Yeah.
There's map views. Then there's GeoJSONs, which is a sort of map view, but a bit more generic.
Yeah.
Just tabular data, as you saw actually in the Excel app, right? The deflection was just numbers. Then there's images. There's PDFs, which are actually quite useful if you're, for example, doing your reporting in your app as well.
Yeah.
You can, in Python, create a PDF file that you can directly show to the user. And then there's HTML. So that's quite...
it's more advanced.
Yeah, it's a bit more advanced, but it gives you a lot of freedom to build a lot of different things. So indeed, I was saying, let's actually add a map view, because, well, just to show you how easy that is again, and how nice that would look. Because I think, yeah, that is quite nice actually. The effort we've made to make it easier for you to build things, really, to my thinking, is paying off. I hope most people would agree with this. But yeah, and now besides my geometry view, there's also a map view showing this very suspicious triangle on the map. Yeah.
And can you, for example, connect this to an Excel sheet like we did before?
Indeed. So that was that's the follow-up point, right? So there's actually a small set of changes that I'm going to make, because I also prepared this a little bit. In fact, let me get you the sheet that I have for this. I will add that sheet to my app and also show it to you on screen, because this is what I would like to connect to again show how
can you zoom in? Oh yeah,
how easy that is. So what I would like to do is extend this app a little bit, so that based on the dimensions of the building and the location, we try to calculate, not in a very engineering robust way, but still the wind load on this building. So we use this formula. There's this little VLOOKUP that happens based on location.
Yeah.
And so I'm going to try and add this logic to connect to this Excel sheet. So the first thing, of course, I need to do is I will extend my parameterization a little bit.
So just to be clear, to understand, so now what you will do is you have the building and you will do a calculation based on the building using the Excel sheet.
Yeah. Indeed. So first I've added some fields and buttons. So you see that I have building width, building length, and the number of floors is just the same as before, right? It's a single line of code per field. I added an option field also in here with the options of where the building can be. You can see that defined in line 16. So it's again quite simple. It's a single line. Location is option field with these options.
Yeah.
You can set a default. For any of these fields, you can do things like set minimum, maximum, suffixes, all that sort of stuff. And I've added a download button, because what we would like to do is when the user clicks this button, the downloaded Excel sheet should be, or the Excel sheet should be downloaded.
Yeah.
In the meantime,
I think that's very nice. So you do the calculation and then you can download the Excel sheet to check if the calculation was done properly, basically. No?
Indeed. Yeah. And that's also, by the way, by default integrated in the sheets that come out of this Excel to App Converter.
Yeah.
They all have a button where you can download the filled-in Excel sheet, because that is one of the risks, obviously, if you build a Victor app around an Excel sheet, that people sort of lose trust.
Yeah.
Because now they have to trust that this is correct.
Yeah.
And that's one of the nice things about Excel sheets, that everyone is familiar with them.
Yeah.
So if you give your end user back the filled-in Excel sheet, it really helps establish that trust, because people can check.
And let's say that the opposite. I'm very concerned about my IP. I don't want people seeing my Excel sheets for some reason. Is that also possible to block it?
Just remove the button, and from that moment on, it's not visible for end users.
Yeah, so people can use the app, but they don't see like the logic behind it.
Yeah,
if you
because
don't want to.
What you see is this sheet is actually in my repository, as you can see it on screen now, right? So this is where the sheet lives. That's also what we mean with control of logic, is that you keep this Excel sheet in only one location, controlled by only the people that have access to this code. So it becomes way easier if there's a new version to enforce the use of the latest version. Yeah.
Great.
So now actually let's write a method to connect to our Excel sheet. In our documentation, we have a special section about it. By the way, there's also the option to download a filled-in Excel sheet template that doesn't do any calculations, but just downloads as a report, basically, right? But in this case, we're going to use the Excel spreadsheet calculator. And this basically explains what we've already talked about, how to add a vector input sheet and a vector output sheet. And then it gives you a small example of how you would use then your Excel sheet. So what you do is you generate a list of these spreadsheet calculation inputs that relate to a specific key that you've defined here, right? You see this is called input key 1 and input key 2. And then you give them a certain value. You call these 3 lines, which spreadsheet am I using? Fill in these values that are just generated and evaluate, and that's it.
So the app fills in those numbers in the Excel sheet. Then it runs the calculation and it gets the results out of that output sheet.
And this we can then use, well, actually in many different ways. So an implementation for me in my small example app actually looks like this. It's Python, so we have to be very specific with our indentation. I've created here a little method that's called getEvaluatedSpreadsheets. It gets, it's a method, so self, and it gets, again, the params. It generates this small list of spreadsheet calculation inputs, which connect to, as you can see on my vector input sheet, width, length, floors, and location. It finds the Excel sheet in my repository. It fills them in and it evaluates. And I can say include filled file because I want to maybe later download that filled in file. Let's also add the imports. And well, this method, it's nice. Currently, I'm not using it, right? There's no method that connects to this app, to this method yet. So let's also add that, and I will do that by adding a data view, which is another view, actually. So our resulting app will have a map view, the 3D geometry view, and now also a data view. And that data view will actually have the calculated results in my spreadsheet. To reload because I added this view. And so if we look here now, we can see that the resulting wind load is now in my app. Right? And that ties to my vector output sheet. I created these 2 areas that I calculate on the sheet, one for the side view and one for the frontal view. And I calculated the wind load in my sheet, and I've tied those to the vector input and output sheet. And you can see that they are reflected here. In fact, I've also, just to showcase that that's also an option, I'm getting these values from my results, right? The same values that I've defined on the output sheet. And then I can do some further post-processing with that in my app. So for example, the maximum area that I'm showcasing to the user is again using Python to compare 2 numbers. So I get these values from my sheet. And then in Python, I do something else with them to show to the user. So if I change anything here, the results will automatically update. So just like before, our resulting app is sort of live connected to this Excel sheet in the background. So that's already quite useful, right?
That's cool.
And in this case, if we didn't have that button, let's actually remove it just to show. So if we now remove this button, from this moment on, the Excel sheet is fully protected. It only lives in this repository, doesn't relate to the end user, he doesn't have to understand it or anything.
That's cool. And we have a question from LinkedIn. It relates again to the template. You mentioned in a certain moment that using the converter, you cannot use macros, but is it only if you use those macros for calculation, or let's say if you have only formulas that link to each other? Is the macro breaking it?
No, I think if you don't use the macros, you should be good.
Okay.
But and if you're not, you could also just save it as an XLSX file, obviously, and then you would be good in any case. But
And let's say you have an Excel sheet with a macro, which is also important for your calculation. But what can you do then? Is it also possible to integrate?
So then you would go about this in the same way that you can connect to a lot of different softwares, actually, from the vector standpoint, third party, obviously. So what you can then do is you download what we call a worker. You install that worker on a server or a laptop you have somewhere alongside your Excel sheet or your Excel installation, and you write some code in your vector app like so that connects to that worker, sends a request over to that worker on your computer, on your server. That worker goes to work, performs the macros, and sends you back a result into your app.
And this is the same way it works with finite element packages and
whatever
not?
So whatever you're connecting to, you see here the list of connections that we have. It all works with the worker.
Great. Yeah, I don't know if there are any questions from the public. Now it's the time to ask. We are about to end this presentation due to time. Pavel says, it looks like a boosted Streamlit.
Well, I think we can take that as a compliment.
It is a compliment. Streamlit is a great product. And we believe we are kind of the Streamlit for engineering. And we have a lot of specific functionalities for engineering. So it's a compliment. Thanks, Pavel.
Thanks. I mean, we are on time. I can go on, but I think maybe we'll have to save it for the next webinar.
Yeah, we have to save it for the next webinar. And by the way, we'll be organizing more of this webinar, also with people outside Victor. So this time, Bruno's a colleague, but next time it will be someone of the industry to share their experience in automating stuff. And again, so if you want to use Victor, you can just go to our website. And you can start building apps for free. You can also publish those apps for free and share it with the world. So just use the QR code or go to our website. And it was great to having you here, Roland. Also you, everyone online. Thanks for being here, and see you the next time.
Yeah, thank you. It was fun to do, and I hope it was useful for a lot of people.
Yeah. And by the way, we'll be sharing the recordings on YouTube and LinkedIn. So if you found this interesting and you want to share it with someone else, we'll add the links to this webinar, to the Excel converter, and where you can get your Victor account. So it was great to have you here. Bye, everyone.
Bye.
See you next time.